Okay, I think it's time to get started. So welcome everyone. Thanks for joining me in this roundtable session about API security. My name is Balint. I'm a senior solutions architect for Imperva. I've been working for Imperva for the last 6 years. I'm an SME for application security in the region, and it's nice to meet you all. So today's session will be about the kind of research that Imperva has been doing into this area. What I will also do is I will walk through some of the summary slides that I have in this topic, presenting on the results of those research, and also I will be giving best practices and recommendations to how best to arm yourself against the variety of threats that we see emerging in the API usage region. So first of all, Imperva is a security company. It has always been a security company. We are doing a great amount of research. I participate in that research as well. So there are quite a few materials available on our website, and I strongly suggest that you head to imperva.com after this session, or wherever comfortable, and get yourself busy. We have a portal available to the open public called Cyber Threat Index. Through Cyber Threat Index, we publish the emerging and current threats as we see going around in the world, and we are also giving not just customers but basically everyone recommendations as to how to best to arm themselves against those. We also have a great amount of research now available into this supply chain security area. We see it's an increasingly hot topic. I'll talk about that in a minute as to why. And we also have a lot of vulnerability research available on the website. So if you just go ahead and do a search for vulnerability, or just head to the URL that I'm sharing, you will be seeing a lot of interesting blog articles in this space. So with regards to the API and the API security, the way we view this area is that API has become the net new honeypot everywhere. Imperva is a data security company. We have a large visibility into how the APIs are used, and more importantly, how the data how the data is flowing through some of the APIs that some of the customers choose to use with us, and also share some information. So only in 2020, we have seen a huge amount of sensitive records being leaked through APIs. So currently the count is at 1.3 billion sensitive records, just of those that we had visibility of or knowledge of. But we are quite certain that this figure is going to increase heavily. 4 primary courses: authorization and authentication related issues. This doesn't mean that this doesn't just mean that we're looking at leaked credentials and leaked credentials being reused against API and API authorization, but also the way the authorization and authentication is implemented in some of the APIs, which some might consider as broken, will lead to this result. Code level exploits, needless to say. However, the log4 shell is not counted in this, with log4 shell being a quite recent one. It is certainly going to add a lot of issues in there. But what we also see is that with the penetration and the proliferation of GraphQL, we're also seeing that some of the old kind of threats that I'm going to talk about so soon also emerging there, with GraphQL being a quite favorite tool where you can actually include a lot of stuff in there, not just one endpoint, one purpose, but multiple statements or complete instruction and even database secure statements if you wanted to into a single query to a single endpoint. So it's quite interesting to see how it's been exploited in that end as well. We're also seeing configuration and management issues. That's mostly and mainly around the design and how the design is enforced for authentication and hardening issues, and of course we're seeing a huge amount of excessive data retrieval and exposure to insecure configuration and and also inadvertent exposure of data due to missing hardening. What we see is that with all of the backends database backends a few years ago, we viewed this area as that, you know, if we had been able to tap into the communication on the back end, no matter what the front end application is or API microservice, then our chances to see the data flowing out was quite high. Today, the way the backend communications today the databases are done is quite changing. There's quite a few interesting use cases when we consider, for example, a MongoDB or Snowflake. Some of the organizations that I work with would use and write a distinct API for a single purpose, that it is no longer a direct database backend access that the administrators or even the microservices can pull data off, but through an API. So even if this old school the data interfaces like SQL and NoSQL, JDBC, and so on interfaces exist, organizations tend to write an API, especially for those those working with the data to actually retrieve the data. Now, that exactly gives a bit more comfort as to how the inputs are synchronized and how data retrieval can be controlled, but it also creates new challenges. It creates new vectors every day, and so some of these APIs are used. Some of these APIs are used quite proliferated in the market. So APIs will drive a single page applications a lot of times. Also, mobile applications, IoT devices, they all use some sort of API to API, microservices to microservices communications, and so this will create a certain challenge of how we can make sure that you actually you don't just protect an API against code level exploits, for example, but how you can recreate the entire audit flow of how your data is accessed from application down to the backend. Complexity brings fragmentation, but of course, vendor consolidation is a thing nowadays, and it is basically a thing on purpose. We usually, when we start to when I start to have a conversation, most of the organization, whoever exposed an API, would have some sort of an API control engine already implemented, API gateways from a number of vendors, but also WAFs, also sort of firewalls, protection for the databases, and so on and so forth. Most of the time, these are not coming from the same vendor, which will actually lead a drastic increase in the number of distinct tools and consoles that administrators and the developers may need to be looking at on a daily basis. There are different consoles, different header files, different plugins, different gateways, and so on and so forth to look at every single day. And it's not just the sheer effort to run the administration of these tools, but also the correlation between how these tools see your data flowing based on metadata, trying to make sense of how how your data is basically accessed through these number of interfaces and tools will also create a huge amount of challenge. With the proliferation of GraphQL, and also the rest of the interfaces, what we are saying is that it is no longer just the fact that you have a math and someone is trying to do the math by running a malicious payload against your API, but it's the fact that they are trying to mimic the behavior of a proper user, a proper browser, a proper microservices, so that not tripping any sort of WAF policies off, but by not loading anything malicious, but things like API pinning and pinning related violations using some sort of a properly automated way is quite high on our list. So it's basically if there is no WAF control that that can look after or that can look at and block these behavior, the only thing you can do yourself is that you code some sort of a logic in your application or your APIs to actually detect if someone is abusing your API, but mimicking a proper user activity. What we also see, well, in many of the European countries for sure, is that there is no law enforcement, that would help organizations to tackle things like unwanted automations. So as long as someone is trying to exploit an application, that's fine. That might be a good and easy way to block it or detect it and report on it. And also the any sort of potential data leakage that leads to it is sort of easy to report on this. There are a number of cloud and cloud WAF based vendors who can offer certain services for it, but yet if you again face a actor who is not using any of these tactics but just trying to mimic the valid user behavior, you are quite effortless, you are quite powerless against them, because they would just use those tools to execute a proper checkout, a proper inventory search, any sort of inventory abuse on the different user entities and so on. So it's quite difficult to sue them in any of the European countries now. Now, of course, there is an EU-wide initiative that will create some recommendations and guidance on this, but there is no sort of deadline, of course, for that. Now, we are doing a huge amount of research on bot mitigation as well, and so what we see is that every day there's a new tool that comes out that has the user create some sort of an automated workflow that checks on the inventory of a retailer, buying sneakers or PS5 and so on and so forth, so they can actually in a matter of seconds can wipe entire inventories out of stock, and that creates certain problems to organizations. What we also do is that the number of supply chain and supply chain related compromises have quite drastically increased over the years. If you think about the exchange hack, if you think about Sunburst and so on and so forth. Now, these are the tools, or these were the tools that actually all the organizations, or most of the organizations, trust to certain degree. Now, why would your APIs be any exclusions to that? So some of the organizations that I work with would use a separate set of APIs to serve their third parties. Things like banks or financial institutions would also use a different set of APIs to run accounting through an external company or retail companies might provide a distinct API, the API endpoints for those resellers who work with them, and so on and so forth. Now, the problem with that, the way we see that is that whilst your public APIs might be protected against a number of different threats or a number of number of different type of data exposures, we also see that some of the API security capabilities and features and products would all provide a single facility to create exceptions for those you trust. Now, as we know, they can also get compromised very easily. So if your APIs are protected by an engine or by a WAF or by a firewall or gateway and so on, that is basically maintain a exception for those you trust, then your chances to be exposed to supply chain compromises is quite high. So it's quite important that you that you arm yourself for cases, and then you treat your supply chain as not your friend, but one of the new attack vectors that will come after you. So until now, most of the API security related business were mostly about OWASP and OWASP related threats, which is quite right. What we are seeing is that bolded are the ones that we are seeing as being on the rise in the last 3 years, as opposed to the the rest of the categories like mass assignment. Is that what we are seeing in the threat and the threat protection area is that the security misconfiguration related issues are increasing. Actually, exactly due to the fact that there are many tools being used, many type of functions, and in cloud native environments protected by some sort of a gateway would require an increasing amount of FTE human resource or analyst resource to not just keep track of the configuration and changing landscape of the API related languages as well, but also the tools that are provided to protect those. So it's using an automated framework, again, not delivering a malicious payload, but just using an automated framework to ping around and poke around in these environments to find out on the application logic, and also to find any sort of missing configuration can be done fairly easily and fastly. So what we are seeing there is that this is definitely going to be an issue, and that companies should prepare, or even developers should prepare to be able to kind of assess their environment for misconfiguration and the lack of hardening. There's also, of course, the excessive data exposure problematic that basically is an issue because the separation between data sets and the data lake environments would basically create a huge amount of comfort for for the data owners, application owners, and the developers to deal with the data. It also creates a huge issue by exposing too much, and things like API pinning and token pinning is the technique that I'm going to try to present today. Is on the rise, and it's very easy to just poke around in an application and trying to pull out any sort of exposed data or excessively exposed data. What we also do is is research into the authorization issues. Again, that's mainly around broken authentication, broken object level authentication and authorization. So as long as you have a user or an API entity existing in some sort of application, your chances that you run into a broken authorization, so that there is no authorization control for some of the data that you can actually reach without you needing that data is quite high. So you might actually find that by just having a simple API and entity or API user who exists, or like an authorization token available to you, your chances to run into some sort of uncontrolled authorization issue is quite high. So what we think is that what we see of the future is that in 2022 is going to be about these three categories mainly. So organizations should really prepare for for the exposure and exploitation of these. What we also view here is that not just so we don't just have to look at these threats individually. We also have to find out that how we can apply an automation by machine learning across the board to keep track and keep an eye on all of the threats and all of the different threats, and not just in one or two microservices, but across the board. So what we are doing at Imperva, and we are investing a great amount of effort into, is that we are trying to have this global visibility of a complete ecosystem of APIs and microservices, and we apply user and entity behavior analytics to find out how the data is used by these different and individual microservices one by one. And so if there's anything that that we can do to detect malicious activity early on, and not just reacting to a certain threat or payload against an attacker. So what you can essentially do is that for most of the cases, I'm trying to speed up a little bit. So it's not just one or two controls that organizations will need to have. There are a number of controls that you need to think about when you consider API security as such. How is your API exposed? What is the purpose of those APIs? Is it a business to business API? Is it a business to customer API? Is it doing some sort of or log on user authorization activity, or is it doing a password reset, or what is the purpose of those? So if you happen to expose a handful of API against multiple purposes, the chance that you will be forced to look at a number of different type of controls for those is quite high. What I mean is that you will certainly need a WAF type of activity to to handle injection type of attacks and malicious payloads. But if you ever do with user activity, then the chance that you will need some sort of a bot control and advanced bot protection against sophisticated frameworks is also quite high. So it's not just that you sanitize your input for injection attacks and malicious payloads, but you would also have to validate the API in context of how a normal browser user would access them. If you don't, if you can, you should stick to a control that can actually interrogate the the client endpoint for any sort of unwanted automation, and try to tokenize on that access, provided that the client who passes your interrogation effort. Now, what you should also take care of is more than obvious, but it's still on the rise with all the compromises of the different large providers with huge amount of credentials now available over the internet, is that you pay special attention around account and account related frauds. And so you make sure that the actual credentials that are being in use are submitted in a way that you would expect a normal user to do, or you would expect a neighboring microservices to do, and so on and so forth. But you essentially use some sort of a control mechanism to check how the credential is submitted and whether or not that's up to that's up to your expectation. Let me just skip to some of so the way we look at API security is the following. What we suggest customers to do is that they start with the discovery phase. So this is now it's quite a available technique. And if we just consider, for example, the data security, so not just API security. So if you deal with a huge amount of data or data set, then you would very probably want to discover what kind of data is that, what you're dealing with. Is it sensitive data? Is it PII? Is it credit card numbers? And so on and so forth. This discovery phase should now be pushed forward to the API layer, because APIs are the ones that will actually be serving this data off to a certain degree, but the APIs will be the ones that will have actually prime visibility into who is requesting that data from what IP address, for what user entity, what API keys, and all sorts of other metadata information is now visible to APIs rather than the web front end. So what we essentially do, and I'm not quite sure if I will have time to present that, but I would be looking for partners and those interested to see this in action. What we essentially do is we push the discovery of the data phase onto the API, so you will be able to see what kind of data by the nature and type are exposed on what API, and therefore we provide a inventory of not just the API endpoints and the type of endpoints and the method they can be called, but also what kind of data are flowing through these. And we would suggest all of our partners and customers and everyone who's using APIs that they start with the discovery phase. They discover what kind of API inventory did they have, or whether those APIs are shadow APIs or they do exist in API specification, and what kind of data those APIs are transmitting. So once you start with discovery, then you will be able to have an up-to-date inventory of what sorts of API you have, what kind of method they can be called, and again what type of data are flowing through them. And also you will be able to test and verify the integrity of those as to whether or not they're only providing the data that they are supposed to be providing. And then if you have this capability, or if you have this information available to you, then you will be able to detect any sort of misuse against those APIs. If you are able to to detect them, then of course you will at some point be able to put some remediation plan around them. The way we view this area is that some of the some of the vendors provide API security in form of some sort of an API gateway that you can put in front of your deployment, in front of your VPC, in front of your Lambda functions, and Fargates, and so on and so forth. Some others offer it as a SaaS platform, and some others will offer it as some sort of a modular gateway or a containerized environment. What we suggest is that you try to opt for a solution that basically covers everything. So with Imperva, what we do essentially is we provide a long list of platforms that we can provide a so-called microservice for, microsensor for. So you can deploy it. You can deploy protection as in form of a Lambda code, or you can include them or require them in your Lambda code, or Fargate. You can use them as the API gateway, but if you want to, you can also use our controllers on an F5 load balancer and so on and so forth, providing you with some sort of coverage. Now, I'm afraid our time is up. What I would like to suggest is that if you guys are interested in any more details and how we do that in production, then please get in touch. Matt shared his email address on the chat. He's my partner in crime, and would love to work with you. And also, if you just want to see this in action with no commitment whatsoever, then feel free to reach out to us, and I would be happy to to present this in action. Now, with that, I would thank you for your attention, and hope you enjoyed this session today, and see you all soon.